right. As I stated in the first hour, we are going to take a look in depth now into different human factors like how we process vision, how you process auditory signals, how we read, how we think, solve problems. So this is more detailed version of, detailed analysis of different human factors. All right. Now, we will start with vision. There are two stages in vision, which is this is the physical reception of stimulus, is our sensory channel, like our cache. So the photons are captured in the retina, and it's then sent to brain. It's processed then, and interpretation of this photons, these visual stimulus, is in the brain. Most of it is in the brain. So the physical reception occurs in the eye. It has mechanism for receiving light and transforming it into chemical, you may call, or electrical energy. And light reflects from objects. And on the retina, actually, the images are projected upside down on the retina, but this is corrected by the brain. And retina contains rods for low light vision. So there are different types of light sensors, like cells, rods and cones. Cones, they are for color vision. Rods are for low light vision, and rods are more dense. They're denser at the peripherals. So you may have this interesting experiment. For example, when you're in a room which has a very low light, you may find that if you look at a straight object, it has go into a room in which it's really low, but there is still some amount of light in that room. And if you look at an object like straight in front of you, that object is invisible. Okay, make the light as low as this much. You cannot see the object if you look directly in front of it. But if you try to look at the same object with your peripheral vision, you may see that even if the lighting conditions did not change in the room, you may actually see that object or it's try to see. You may see its boundary with the peripheral vision. All right, so this is because these roads, there are roads that are denser in our peripheral vision, and they can actually sense this low light vision better than the cones. So, but this experiment setting, it has to be really, there's a threshold where, if you make the room too dark, you cannot even see in roads. Okay, with rods. And this is probably in evolution, this is like a defense mechanism to catch movement in our peripheries, to catch movement in dark conditions in our peripheral vision, is again how the eye evolved in maybe millions of years. And the pattern and movement is actually detected by the ganglion cells in the brain. But when we interpret the signal, the size and depth of the objects, they give us certain clues as to how, for example, how far away from us. So the visual angle indicates how much of the view the object occupies. And visual acuity, acuity is the process of perceiving detail. Yeah, actually it's written right here. And blue acuity, for example, is lowest. So this is when you're trying to provide something in detail on an interface, you shouldn't make it blue, those detailed parts, for example. And familiar objects that we perceive them as constant size in spite of changes in visual angle. And some of these signal interpretation, they lead actually to optical illusions like this. For example, because we think that this is like a ladder, and our expectation is that this ladder has two sides that are parallel to each other. So we try to perceive it as parallel, but and therefore an object that is sitting on the ladder that is here is perceived longer than an object that is here. Actually, these rectangles, if you just take this rectangle out here, you see that it's exactly the same length as this rectangle. or the extension, arrow extensions. This illusion, we also perceive the line segment in between the extension. We perceive it as also longer than the line segment that is here. So there are different optical illusions you can find. But we make lots of visual cues like shadow. Shadow is really an important cue as to understanding whether an object is floating on top of something or exactly on the table. So they cues overlapping. They help perception of size and depth. So our brains make these interpretations automatically. We don't even think about certain things when we are doing those. And actually, the illusionists make use of these brains' different ways of interpretation of these signals to provide illusions to us. Brightness also is really something subjective. We may think that a piece of paper is white inside the room, but if we actually we have the same brightness level in an outside sunny environment, the same paper actually, if it doesn't change, it will probably appear like a dark gray or something. So it's really what the way we perceive intensity, the brightness is really subjective. We look at its surroundings. Uh, and context is really important. We make use of context a lot when we are interpreting things. Yeah, this is what I told before. Blue acuity, perceiving detail in blue color is the lowest. And this is also a really high percentage. 8% of males and 1% of females are colorblind. And there's also actually levels of color blindness. So it's not something binary. There's a level of color blindness. So when 8% of the males are colorblind, this may be in different levels, but you need to know this in order when we are designing interfaces in which there's a color in between red and there's some greenish reddish color, and there's some color similar to that. They may not distinguish between those two. Okay. Usually in interfaces, the color and three-dimensional graphics are used badly in interfaces a lot. So I'm skipping these slides, some guidelines for how to use color, and they're also related to what kind of a color palette is good for interfaces. There are aesthetics involved in this, obviously, but there are also usability issues, like you have to have good contrast if you want to have something visible. It has to have a different color than the background. And we use context a lot to resolve ambiguities. Our visual system brain compensates for movement, change in luminance. And we may have optical illusions due to overcompensation as well. And when we're reading a text, so this reading means when the humans read a text, the reading actually occurs in several stages. We first perceive the visual pattern, we decode it into words. Sometimes we just perceive them word by word. We don't read it letter by letter. There's a nice experiment, for example. If you just take some of the vowels out, you will still be able to read it as a correct and in a fast manner. And the interpretation of the entire the sentence is done using knowledge of syntax, semantics, knowledge of the language. So we make use of our long-term memory while we are reading. And well, when we're reading a text, also our eye movements they have certain patterns. So sometimes we have rapid movements. So these saccades are rapid movements of the eye pupil, and sometimes we fixate on certain spots. And the perception, the understanding of the sentence actually occur during those fixation parts. Word shape, the type of font you use is also important to recognition. And now we jump to auditory signals, hearing. Hearing also provides lots of information that most of us are not aware of. It may give us information about distances, directions, which objects are there. And our physical apparatus in humans or other animals are we have the outer inner ear, middle ear, and the inner ear. And the characteristics of sound usually are indicated in three different parts. Pitch is the note of the sound, whether it's a low or high in terms of note. It's the frequency. Uh, oh, so exactly. So when if you have the uh, deuteranopia, it's about a green color. You may the good thing is that so what Doa shared with us is that so because of this visual perception difference, he really needs an interface that is customizable, right? So if there's an interface, um, if the interface is not customizable or the monitor is not customizable, this will provide this will result in a difficulty when interacting with the interface or in a game. So it's really you need to switch this default to Deuteranopia because I mean if the operating system provides that switch, that's a really good thing, and it allows you to compensate for this condition. And in terms of sound, there is also loudness, the volume of the sound, is this amplitude. Timbre is the type or quality. For example, a piano may hit the same note. For example, if you press the middle C in the piano, the same volume, it's going to have a certain sound. If you do the same thing with a violin, it will sound differently, right? So this is how the sound may still have the same frequency, but the changes in frequency, its average frequency is like makes it the note C. The different instruments have different timbres. Timbre is like the type of instrument, the texture. It's like the texture of the sound. Wow, that's really interesting. If it works, then if you recognize it as a different color, though, then it makes. This customization really helps you use the interface more effectively. So we are going to talk about this when we come to adaptable interfaces. But really, this is a difference between human factors in terms of vision has to be taken into account if you want to develop effective interfaces. And there's also you need to also know our limitations about between which frequencies we can hear from 20 hertz to 15 kilohertz, and we have less accurate distinguishing high frequencies than low frequencies. Okay, so two things that are both in high frequencies, it's more difficult to distinguish them than in low frequencies. This one has these frequencies also has an interesting story about it in terms of analog telephone lines. The analog telephone lines actually they were not transmitting sound between these frequencies. They had really limited range. Okay, but this limited range somehow the distinguishing part of certain words like F and S. Okay, so F as in fun or fanfare, S as in sound. The F and S probably in certain phone lines, if you just spell those letters, the party on the other side may difficult distinguish between these two things. That's why we encode them and we say like F in fanfare, F in fun, or S in sound. The reason we have to do this encoding is that because of the frequency, the distinguishing parts of those letters, especially maybe we are doing the distinguishing with visual signals. Maybe visual signals also help, and in in telephone conversation, we are limited to audio channel only. Therefore, it may even make it more difficult to distinguish between different spellings of letters that are very much like alike in certain frequency ranges. Wow. So really, so it's only recently becoming. So what Utku shared is that to include colorblind options. This being very just being recently. It's sad actually. It should have been recognized earlier. But people are becoming more aware about these user interface issues, and it's good that games are more adaptable to different situations these days. Yeah. Dyslexia friendly font, colorblind option, detailed closed captions for hearing impaired users. Exactly. So these things are really important, and it shows that such an interface considers all different human factors into account, and the variability in human factors are taken into account in those interfaces. So the good usable interfaces should actually do that. They should be customizable. They should have all these informations. Uh, After auditory, there's also touch. We detect whether something is soft or hard. Whether, for example, when you're typing on a keyboard, the sound you perceive, the type, or whether the feeling that the key is pressed is really helpful to understand that you have pressed that key or not. All right, so we get touch feedback with our fingers, and we also provide touching output via to the interface with our fingers. That's the bad thing for virtual keyboards when we don't get a haptic feedback, haptic output when you press something. And some phones actually all the phones have that, but it's still you don't get the vibration. Some of them when you typing on a virtual keyboard, you also get the vibration effect just to give you the feeling, that touch feeling, the haptic feedback to tell you that that key is pressed. So that's helping, but still, that since the entire phone vibrates, this still doesn't help that much. It's still physical keyboards in that sense. About the haptic key feedback, physical keyboards are better than the virtual keyboards. And different parts of skin, different parts of the body have different sensitivity. And the kinesthesis is the concept of awareness of body position, whether you're sitting, doing the same thing when you're upside down may be a lot difficult to do. And whether you're aware of your body position or you're not aware of your body position also affects comfort and performance. So these are things about touch. Movement is time taking to respond to certain stimulus. For example, you hear something and you raise your hand. You see something, you raise your hand. That's movement, and it is composed of reaction time and movement time. First, you see, for example, imagine there are lots of lights flashing in front of you, and you're asked to raise your hand only if that light is red. All right, so you're seeing lots of flashing lights. Whenever the first time you see red, the reaction time is understanding that signal and understanding that it's red. Then time is just the raising your hand, and the movement time may be dependent on age, fitness, and one interesting thing here about the different stimulus type and our reaction type to different stimuli, you see the auditory reaction time is fastest. And it's interesting, the haptic feedback, the response to pain is slowest compared to visual or so if you get pinched, understanding that takes 700 milliseconds. And usually reacting to auditory signals, on the other hand, is much faster than the others. And as I said, people have developed different models to as mathematical models to understand how fast people are going to react to certain things, or click on certain parts on an interface. One such model is called Fitts law. We are not going to go into details of this, but I just want to show you that it's a mathematical model that describes the time taken to hit a screen target. For example, there's a button and your goal is to press that button. That button is that screen target. And this is the movement time. And there are some constants here which are empirically determined, A and B. But this basically tells that the two variable things here are the distance and the size of the target. So the longer the distance, the more time it takes. So this is, and also the larger the larger size buttons, it's faster to hit that button. So this is also indicating it's inversely proportional to the size of what the area that you want to move with your mouse and how far away from the current mouse position. And also getting users' attention in user interfaces is also another human factor. Selecting things to concentrate on from the mass around us. So we are seeing our visual or auditory stimuli have lots of signals coming all the time, and we actually filter them. So the attention is the process of filtering certain things out and focusing on certain part of the visual signals. And the focused and divided attention enables us to be selective. So we filter certain things. And we cannot keep track of, this limits our keeping track of all events. And magicians use this to their advantage. They help make us focus on somewhere while they're doing something else in another part of our visual signal. It may be in front of us, in front of our faces, but we may still be not perceiving what the magician is doing. So these are, if you want to get user attention to a certain part of the interface, you can use some visual cues like different color or blinking phones or reverse video. So we need to really, if you want user to look at certain parts of the interface, you have to do something different in that part of the interface. But you do not expect, this is what also saying, that do not expect the user to pay attention to all parts of your interface. If a certain part needs more attention, you have to have some actions on the interface. This is what it's telling basically. There are different user evaluation technologies like eye tracking technologies, gaze tracking technologies, which help evaluate user interfaces in terms of where the users are looking at when certain things happen on an interface. So with that, for example, you can identify problems that you haven't thought of before. If you may see that the user never looks at a certain location. So for example, in Oculus, what I don't like in Oculus here, there are lots of usability problems in Oculus as well. For example, when I enter Oculus only most of the time to add an assignment, to add some file, but by default it's not doable. I cannot edit right now. There is a button right on the upper right corner, which I rarely look at most of the time because all the menus are here, right? My attention, my gaze is on this side. And most of the time, this may be overlooked. I may not look at the turn editing because it's right under my username. I'm going to pay attention to this part only when I'm logging out. All right. So it may be a bad idea to put this turn editing on top right. And it's not visible when you scroll down. As you can see, it's not visible at all. So you have to be at the top of the page and see this turn editing on. When you click on it, the interface changes and you can now add certain activities and resources on Oculus. Okay, and by default it's off. That's another thing. Maybe by default it should be on. And you should just click on this to turn it off if you want to turn it off. That's another thing. I mean, this may be a usability problem if you see the frequency of tasks. The Oculus users, especially, for example, a teacher. So right now I'm logged in as a teacher. So Oculus knows my role. All right, that's why this turn editing button is there. If users with teaching roles use Oculus most of the time to add an assignment or to add a file to make additions to these weeks. If this is most of the time why we log in AutoClass, I definitely think that the editing on should be turn editing should be on by default. All right, so because it makes it another step to turn it on. Oh, the FNZ pattern principles. I didn't understand your question, Berfu. So is it about my AutoClass comment or something else? I maybe missed your chat comment earlier if it was about something else, and I didn't get it. The FNZ pattern principles. It was it about the attention maybe or oh, our attention on the web. Yeah, 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 exactly. Maybe, but yeah. So there may be different pattern principles here, and people use these eye and gaze tracking applications. And why? Yeah, maybe we don't pay attention to upper right corner. Maybe in certain cases we may. I don't know. Maybe because of uh, most menus are on the left and they're apparent like this. They may be our focus may be on this side. I don't know. Yeah, maybe when we're writing our letters, we start from the lower left. So most of the things are here. It tells me there are also good things here, like helps my short-term memory. I don't. By just looking at this, I may immediately remember where I am. I'm currently in this course, and it's in this program. I may go to the dashboard by click on this. And this left menu also helps to go over between different things. I can go over participants, uh, the main web page. So yeah, it may be, and I don't know why they put it here, but it was a difficulty for me. Maybe for different users it may be easier, but there are some usability problems with this interface, and because of that, they had to do lots of AutoClass training so that users can use it effectively. If a really nice usable interface should not need a lot of training. Okay. Anyway, yeah. So this was, about attention. If and our gaze may wander in different places, and we shouldn't assume. My main take from here was we shouldn't assume user looks at everywhere on an interface. If some certain important part of the interface is a frequently click button or use function, it should be apparent. It should be in the middle of the screen, maybe at the top of the screen in the middle. We shouldn't assume the user is going to look at every part of all of the page. There are different design implications for attention. Make information salient, apparent when it needs attending to. Use techniques that make things stand out, like color, ordering, spacing, underlying, sequencing, grouping objects together, using some animation. But you shouldn't use these unnecessarily. It may be very annoying just to take user attention. You shouldn't have the user attention all over the place. We should also avoid cluttering the interface. Simple interfaces are better. We should avoid using too much. If just because the software allows it, we shouldn't just put different blinking, different things everywhere, colors everywhere. So it should be simple. But if certain parts of the interface needs attention, we should use something different for those parts. So these are some examples of overuse of graphics. And perception and recognition is again related to how information is acquired from the world and transformed into experiences. And some implications to design. Text should be legible. The font size should be large enough. Icons should be easy to distinguish and read. For example, I still find it difficult on interface of YouTube on some TV applications or in Apple TV or in different things. We have this YouTube application. Everything is in icon these days. And I always have find it difficult about the last two icons. One of them is library, the other is history. Or I mean, actually, history is inside the library bar, but there are two things on YouTube at the end. I always click on first and one of them and cannot find. Oh, history was not in this one, and I click the other icon. So those icons mean nothing to me. I think one of them is. Your library and the other is the general library, so it's maybe the icons are here on YouTube too. If I find those icons, yeah, oh no, these they actually make more sense here. Maybe this one. Oh, it's one of them is subscriptions and library. Yeah, I mix these two, the subscription and library icons. Look at them. Now, since the web interface is nice, okay, they have some descriptions next to them. So the web interface is saying, okay, so it says subscriptions right next to it, and there's library next to it. Imagine an interface in which these textual descriptions are not there, and at the bottom, you see these two icons. One of them is this, the other is this. They are almost identical to me, just a rectangle or a square with a play button on it and a bunch of them on top of each other. So which one is library, which one is subscriptions really is arbitrary for me. It doesn't make any sense. So I never learn. Another thing is I never learn which one is which. So I always try pressing the one at the bottom or at the top, and then with two tries I find what I'm looking for. Oh, history is here in this one. So that's an example of a bad use of icons, actually. The icons are not distinguishable from each other, and they don't really relate to what they mean. Why is it may I mean, the designer of the icon probably has, oh, okay, there's this play button, there's a bunch of things that go underneath, there's some semantics to it. It's like history, but yes, subscriptions, I don't know. I mean, maybe they could have just used the letter S to indicate subscriptions. I don't know. So, but just icons, using icons all the time. When the icons, the population of icons gets a lot number of icons, it may be very difficult to use that interface. So here are different use of background color, font. If we have, this is really bad contrast, bad texture, but I'm going to skip these. Now I'm going to talk a little bit about memory. So, in terms of memory, we talked about already three types of memory, different speed, and there is the sensory memory, short-term memory, and long-term memory. With rehearsal and practice and experience, things get to our long-term memory. Short-term memory is about our attention and the current working memory, which is constantly overwritten. Sensory memories are also overwritten. And there is the thing about the recognition versus recall. There is an optional reading. There was an optional reading for this week. If you go ahead and take a look at the course website. It's here. In week 3, recognition over recall. It's about human factors related to memory. Recognition is the process of seeing something and then making sense of it. Recall is getting the experience or memory of it without seeing it. So being able to recall things are actually difficult than recognition. This is like the comparison between multiple choice tests and classical tests. In classical tests, students like multiple choice better because even if they don't study for the exam, when they see a choice, they may recognize the correct answer. If the choice was not present in the multiple choice in classical exams, they need to recall that information from scratch. So recognition most of the time is better than recall. The graphical user interfaces utilize recognition than command line interfaces. In a command line interface, all the commands that you have to type, they need to be in your memory and you need to recall them. So what was this? How did we, for example, search a keyword in a file in Linux? So you need to know that grep command, what the parameters are. But graphical user interfaces just presents you these things, so you just recognize when you see those things. We are better at remembering images than words, but as I said, some images, if there are many images and they are ambiguous, using all the time icons in an interface is not a good thing. So the use of icon name rather than names is being used a lot in interfaces these days. But what I'm saying is that this is not always, not necessarily better, okay? Especially when icons may mean multiple things. So there are different sensors, the visual, audio, tactile, different. We have different. These are named iconic memory, our short sensory memory for visual stimuli. Echoic memory is our constantly overwritten sensory memory for sound, and this is for touch. Sensory memory is constantly overwritten. Short-term memory is like a scratch pad for temporary recall. It's really just like uh, memories on computers. It's rapid access and it decays very rapidly. We forget very quickly, and it has limited capacity, usually 7 plus or minus 2 chunks. You can, if somebody tells you a 20-digit number, it's really difficult to just repeat it back if you don't memorize it and put it in your long-term memory. If you see it like this, it's difficult to just comprehend this entire long number in one shot. And therefore, if this is like some phone number or some address, we usually present it in chunks. Okay, so 01, 21, 414, 26, 26. So it helps us to convey the information better. And also, if we have letters, we also present it in chunks if the person is to use this in some interface. And there's the problem. People have understood this 7 plus minus 2 chunks short-term memory wrong when they were designing interfaces. For example, designers put only 7 items in a menu, which is doesn't make sense because there may be many items in a menu. There can be more than 7. It doesn't matter, right? There I can have icons like this. I don't necessarily need to have 7 icons here just because of my short-term memory. I don't need my short-term memory to take a look at and recognize what these do. Okay, so people have used this finding about the short-term memory incorrectly when they design interfaces. Some designers present only 7 options in a menu, display only 7 icons on a toolbar. So this doesn't make sense. This is a wrong application of the theory to interfaces because we can recognize more things. That's why it's wrong. People still can scan lists of bullets, tabs, menu items, and they don't have to recall them from memory. Briefly seeing them will be sufficient to be able to use it correctly. And long-term memory, I'm going to actually quickly go over the long-term memory. There are different ways we use our long-term memory, different ways to represent this semantic memory structure. Our knowledge is represented differently in the brain. There's a model that is based on semantic networks, the information is like a knowledge graph. There may be relationships between concepts in this graph. So this is a semantic network model of long-term memory. But this may not be true. There are in cognitive science. So this is actually the area of cognitive science, and they may discuss this in more detail. In this course, we're not going to focus too much on this long-term memory part, so I'm going to skip these. And there may be different models. The semantic network is not the only model. There's a frame model in which information is organized in frames and placeholders like this, where you put your knowledge there. There may be scripts, scenarios, where certain events may trigger our memory of other events. So there may be certain cause action type of relationship between different events. So there is a time-based long-term memory, event-based long-term memory, and we may have different production rules. So this goes into how we make our intelligence to solve problems, to make deduction. We may have some condition action rules. If this happens, then this happens type of things. There's if then else relationships between different cause and action, the results of those actions. And the long term memory is constructed. The information is stored with practice by doing rehearsal. There is this total time hypothesis saying that the amount of um, knowledge that is retained, that is going to remain in the brain, in our long term memory, is proportional to rehearsal time. If you rehearse something more, it's going to be retained more. Maybe, for example, if you just study, if you just study this subject just before the midterm exam or the final exam, then you may just forget it easily after the course semester ends. Also, if you distribute your repetitions over a period of time, it also helps retaining of that information in long-term memory. Instead of focusing only on a single day to study all the subjects, again, the retention may not be that much. But if you distribute your rehearsal or your practice of this knowledge over a long period of time, and it also helps storing that information in long-term memory. And sometimes you make analogies to when you're learning things. Oh, this looks similar to that one. This is similar to this one. You make analogies. You see the structure pattern in certain knowledge, and this also helps you to store them in long-term memory. We also forget things. In long-term memory, information is lost gradually but very slowly. Age, different human factors like age, uh, emotion, they may affect this. Interference, new information sometimes replaces old information. But sometimes there is retroactive interference. Old information may interfere with the new, which is called proactive inhibition. Uh, and so memory, we may not forget at all. The memory is also selective, which is also affected by emotion. We can subconsciously choose to forget. And yeah, I mentioned the difference between recall and recognition. Recall is information reproduced from memory, and the recall can be assisted by cues. Like when I try to recall something, if I remember its first letter, it helps me to recall the entire name. But when I see it, recognition is much faster. If I see what I'm looking for, oh, it's this one, I will immediately recognize it and see, okay, this is what I'm looking for. It's less complex than recall. Here, the information, when we see it, it's the cue itself. And we also use our intellect to do thinking, reasoning, problem solving. There are different reasonings we do. We deduce things. We use induction. There's abduction, deductive reasoning. Deductive reasoning and deduction is basically driving the logically necessary conclusion from the given premises. For example, if you have this knowledge, if it's Friday, then she will go to work. If I know that it's Friday, then I can deduce that, oh, she's going to go to work. This kind of reasoning. And there may sometimes the truth and logical validity. Some people are babies, some babies cry. So this is not deductive. So some people cried, which is correct actually, but this is not because when we say some people cry, we may not actually infer to babies when we say some people cry. It may have a totally different meaning when we say some people cry. Um, there is also inductive reasoning. We sometimes which may lead to incorrect results. We generalize from cases that we have seen to cases that are unseen. So this is like extrapolation of our knowledge. Inductive reasoning, you can remember this as an extrapolation of our knowledge, of our practice. Uh, it may be unreliable sometimes. And also, humans are not very good at using negative evidence when in reasoning. And one example here, this experiment is this Wayson's cards. When we're faced with a set of cards like this and we're given this information, if a card has a vowel on one side, it has an even number on the other. So with this information, we immediately go to this one. We use deductive reasoning. So, oh, sorry, not this one. The vowel is this. Okay. So if a card has a vowel on one side, we go to this one and see that I know that it's using this information, I can turn this card over and I'm going to see an even card on the other. Okay. But what about the other cards? Can we have? Can we do something? What about the negative information? How many? In order to figure out whether this statement is true or not, which card should I turn? For example, since we set an even number, we will turn this one. It will, if there is a vowel on the other side, it will be another evidence. So we first need to turn this card over to see whether there's an even number on the other side, right? Actually, this should be another thing that we should turn over. If there's a vowel on the other side, this should be a negative evidence that this statement is not true. So we may not directly go ahead and try to, since this is talking about even numbers and vowels, we would immediately focus on these cards, but they also, and we shouldn't actually turn this card over at all because this statement has nothing to do with consonants. So K is a consonant. It doesn't say anything about if there's a consonant, there's an odd number on the other side. It doesn't say anything like this. So this is just an example saying that negative information is more difficult to use. There's abductive reasoning, which is reasoning from some events to cause, and it can also be unreliable like this. There are we also solve problems. It's the process of finding a solution to an unfamiliar task. Especially, we do this problem solving a lot in games, especially in games where some puzzles are involved. There are different theories, the models that try to explain how people solve problems. There's this Gestalt. Gestalt is one of the researchers who worked a lot in cognitive science in terms of these human factors. And he stated that problem solving is both productive and reproductive. And productive draws on insight and restructuring. Restructuring the problem is really important. If you want to gain a new insight to the problem, you need to look at the same problem from a different perspective. But I'm going. Yeah, this is really most of these are the area of cognitive science, and I'm going to skip these parts. Problem solving. There are different reasons where we make errors. I talked about different types of errors. Sometimes we make errors because of slips, which means there are unintentional errors. We have the correct intention when we are using the interface, but what we do this error unintentionally. These kinds of error are called slips. It may indicate some problem with the user interface, but we may also sometimes make mistakes, which means our problem solving or the way we try to use the interface was wrong. We had the wrong intention. For example, if you want to insert some picture in a presentation like this, if you just click on view to do that intentionally, it means you're making a mistake. It's not under view, it's under insert. Okay, but when you try to click on insert, you accidentally click design. It may be an example of slippage. So we talked about mental models in last week, right? I also gave this example of thermostat control heater versus the valve mental model. The same example is here. People develop mental models when they use an interface. So this is a repetition of what we talked about last week, and some new examples are here. A mental model is an internal construction of some aspect of the interface or the external world. And when we are doing mental models, we build mental models from things that are similar. Some models may be deeper, some models are more shallow, so there are different detailed levels. So here is an example that I gave last week. So we arrive home on a cold winter's night to a cold house. How do you get the house to warm up as quickly as possible? Set the thermostat to be at its highest or to the desired temperature. We usually do this thing. We set it to the highest level. because we apply the valve model. But maybe it's the speed. I mean, setting the thermostat, yeah, maybe burn the house. That may be even better. That's going to be warmest, the fastest way. But yeah, thermostat control heaters, setting the thermostat at a higher level does not. They may not change the speed at all. But uh, I think there's also some logic to this one. You first make the house, maybe the thermostat is to heat to heat to dissipate. If you want the heat to dissipate to everywhere in the house, you may first heat it a lot. Then it's going to parts of the. I mean, where this thermostat is measuring temperature from is really important. But if the thermostat controlled heater is measuring the current ambient temperature in the house, then it really doesn't make sense to turn it to the highest level. So this is another one. You're at home starving hard. You look in the fridge and find all that is left is uncooked pizza. You have an electric oven. Electric oven. Do you warm it up to 375 degrees first and put it in the instruction, or turn the oven up higher and try to warm up quicker? Again, this is also thermostat control, both of them. Because we may have the thermostat control things, many people have erroneous mental models because of this valve theory, where more is more principle is generalized in different settings. The gas pedal, if you press the gas pedal more, the car accelerates faster. If you have a gas cooker, if you turn the gas more, you will get more heat. The tap water, if you turn on the tap more, if you turn the tap to get higher pressure, water is from the tap. Also the radio volume. If you turn the volume more, you get more amplitude in sound. So these are all different interface models in which the valve theory is applicable. But thermostats, if they are based on on-off switch map model, applying this valve model to them really doesn't make sense. Okay, so also we also make different mental models. For example, when a screen freezes, most people will try to hit their monitors, okay, because something freezes. If you hit it, it's going to move, right? So this is again application of a different. I mean, hitting your monitor will do nothing to make your computer unfreeze. Okay, so or hitting lots of keys to make it unfreeze again. It doesn't. These are again different analogies applied to these settings. There is also the concept of external cognition. I'm going to skip these, but externalizing to reduce memory load is important, like using calendars on Gmail. I use Google Calendar a lot to reduce my memory load. I don't need to memorize what I'm going to do next week because I externalize my memory load to somewhere else. People use shopping lists, to-do lists, calendars, notes, post-it, marked emails. They help us externalize our memory load to somewhere else. Okay, so this is also important. Computational offloading is similar to that too. So I'm skipping the rest of them. Emotion, I'm not going to talk about emotion, but you can read the remaining slides, how emotion affects different parts. These are some of the things I already mentioned these, like under stress, we're going to make more errors. Relaxed users will be more forgiving of shortcomings in design, or aesthetically pleasing and rewarding interfaces will increase the positive effect. Things like these we already mentioned. And people are different. When we talk about all those human differences, you see that people are different. There are long-term differences, short-term differences, changing dynamic differences, like age is something changing. Now, when you're designing an interface, you should ask this question to yourself. When I make this design like this, which part of the population I'm going to not consider? My design decisions, does it exclude certain sections of user population? So this is really an important question when we should ask ourselves when we are designing interfaces. When we make a design choice to put something there, to make it a gray color, to make it a green color, so we should ask does this really cater to all of the user population, my target population, or am I leaving certain parts out? Certain parts of the population out is what we should ask ourselves. These are again repetitions, and the all these human factors, it may be difficult to think of them ahead when you're designing an interface. Therefore, in order to make sure we take into account these human factors into account nicely, effectively, one way to do that is to involve users in the design, because we are not cognitive science experts. We don't know all the details about, oh, this type of vision is good, this type of hearing is good, or oh, maybe you may never know that, okay, distinguishing sound in high frequencies is worse than distinguishing sound in lower frequencies, different sounds. So we may not know these things. We are not cognitive science experts, human factor experts. But the way we are going to take into account these human factors is by involving our users in the design process. At the very least, we should talk to users. We may need to do contextual inquiries, meaning that interview the users in their usage place during their normal routine. And also, this is what we are going to spend the week here in this course to talk about how we create prototypes. There are different levels of prototypes. Early in the design process, we are going to create prototypes that are very crude, not detailed, but they will still tell something about the design choices, and we may show them to the users and make the users use those prototypes in certain tasks actually. So this is really important. The purpose of creating prototype, the main purpose of creating prototypes is to involve users in the design process. That's the reason we create prototypes. Okay, and users are really good at giving feedback for something that is even partially built. Just giving feedback on just textual description may not be easy. So when they see something, oh, I didn't expect that it's going to be this big or this small. So seeing even a mock-up version, a cardboard, you may have a cardboard prototype of what you plan to do at the end. And this cardboard prototype may give an idea about how it's going to feel in the user's hand, or its size. These things are really important. So prototyping is a really critical activity in user interface design. Yeah, and this is my last slide. So your first reading assignment addresses some of these human factors, like being elderly is more difficult. For example, one of the conclusions from the paper that I remembered is that elderly people, divided attention is a bigger problem for them than compared to younger people. Divided attention is the process of, for example, when you're using an interface, you have to look at certain part of the interface and looking at the other part, and dividing your attention between these two parts to perform a single task. And in driver navigation, when you are using your Google Maps on your phone and you put your phone on the dashboard to see where you're going to turn, if you need to look at the map, you're actually dividing your attention between the road and the interface. And this may have worse implications for elderly users when divided attention is something more difficult to do. So the paper addresses these topics. So it will be an easy read. You don't need to go into too much into technical details, but it has lots of important good parts about how to conduct evaluation, how to set up your experiments, how to develop a prototype. Okay, so it has things about developing a prototype, doing the evaluation. So this is a really nice paper that I like, and I usually give this as a first paper in this course because it covers many aspects of user interface design and its usability evaluation tests. So I hope you'll enjoy the paper too. And again, we are going to have a quiz next week on April 9th. We are going to have a quiz from this paper, 2 questions, multiple choice. Both of them are multiple choice questions. and it will probably take 1 minute for you to solve this quiz next week if you read the assignment. Okay, and the assignment is both on the scheduled section of the course web page here, and also on AutoClass uh, under this week's materials, reading assignment 1. All right, it's not as an assignment, it's just a PDF file. So you'll not be able to submit anything. The quiz is not going to be here. The quiz is going to be visible here next week during our lecture on April 9th. There's going to be a quiz. So you'll have to log into your AutoClass accounts. When I say the quiz is available now, you will be able to submit your answers in 10 minutes. So I will give you 10 minutes during the break. You will be able to submit your answers. So if you can not make it to this 10 minutes, I will not open the quiz again for those who missed this opportunity. So quiz is like an in-class synchronous event. All right. So if you're not able to make it to this lecture that day, you'll be missing one of the quizzes. But we're going to have many of them, like at least 8 of them. So missing one hopefully is not going to hurt your final grade that much. All right. So that's it from me today. I will stop recording now.